The OpenRC, you know it as a model from Daniel Noré, and it looks this big, but we went on ourselves a little journey. We did a video where I showed you a bunch of parts, and then Bill Duran of Punished Props Academy and we glued some stuff together. I showed you how to make screws. I showed you how to make bearing shapes, I called them, but I know that they're bushings now. I think Robert himself put a bunch of electronics in it. We did a change to the motor mount, and now, finally, we have the OpenRC, the world's largest OpenRC. It's 4x scale, and we're gonna see if it runs for the first time right here on 3D Printing Nerd. A lot of people had a worry about the PLA material because it's all PLA, and people thought you're gonna heat the axles to some sort of heat death, and we took care of that because we used some graphene powder and we put it on all the bushings, we put it on the axle. The motor has been tuned down a bit, so we get a maximum of 15% power. I know that this is not a standard RC controller, but we made it work. We've got right, we've got left, and we should have go. So this is the first time I have a studio audience. This is fantastic. We're gonna roll it that way. We're gonna see what happens. Okay, here we go. Did we chew a belt?
Yeah, belt's gone.
See, we still have there. The belt stretched a little bit. We still have teeth. Yeah, belt stretched a little bit. So we just need to tighten it down. It's actually working, which is fantastic. I think it would have been proper to have a tensioner. Maybe the next version. Okay.
There you go.
A few moments later.
Way harder than just making the bearing work.
Belt delivery! So we've come to a conclusion for this OpenRC build, and Robert's gonna take the tire off. A lot of people thought that the plastic bushings were actually gonna melt, and we were gonna weld them to the axle or to other parts of the car. But that didn't happen. That didn't happen. With the graphene powder we added probably aided in not doing that, but what's happening is we are reducing the outer diameter of the bushings because it's wearing away the plastic at a rate that's faster than what I or anyone else was expecting. Although there's probably people on the internet saying, I told you so, and that's fine. But we've got 10 belts to run through. We're gonna run through a few more before we run out and grab a celebratory beer, but it's not a failure if you learn something.
Perfect.
Right? Right. I'm talking to Robert, he's not answering, it's okay.
Yes.
It's slipping the belt.
It's slipping the belt because it's loose.
We're back in the studio, and we've got the car right here. And I know a number of you are going to be entirely super disappointed because it didn't just zoom down the parking lot, roadway, whatever we were on, because, well, it just didn't. It was plastic on plastic. Although most people said it won't work. Plastic on plastic, it'll just weld itself together. That's not what we experienced. We didn't experience the plastic melting together because of high temperatures. What we experienced was, well, more like a sandpaper effect. The plastic on plastic kept eroding away at the outer diameter of the axle, bringing it closer to the motor, which then loosened the belt, and that's why it would go wzzz, 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 and it wouldn't be able to power the car forward. So that's what we're working with, or at least that's the idea we're going forward with. We still need to take this apart to verify, and that's what we're gonna do. I'm gonna take this back end apart. Give me a second. I'm sure you'll get yourself a chantage. Let's see if I can get a camera over here. Look at that. The first thing I saw as I took the cover off is, well, this. It looks like it's chewed up plastic. So we did, oh yeah, we did get some melt, but it wasn't, because we don't have it on this side. We only have it on this side. And it was where the compression of the plastics was happening because we had to tighten the belt against this. And this is exactly where a bearing would have come in handy. It looks like we need to get this off. Hold tight. You can see some of the graphite powder in here. This is free and clear, but let's get the other wheel off. This is fine. The teeth profile matched up just fine. In fact, the belt grabbed onto this extremely well. I think there's so much surface area and so many teeth to grab onto, super easy. However, this part right here, that part right there, that was one of the issues. But again, so we've actually freed up the axle a bit. Okay, let's get this off. So if we look right here, it looks like friction did take a toll, but not nearly as much as I thought it might. It looks like the graphite powder did play a role in freeing this up. In fact, if you look right in there, you can tell that it got in there and it provided some lubrication to that surface. So that's good. But here's the big one. Here we go. Here we go. Oh my, okay, first look at the deformation right there. Oh, and then right there. Look at that in there. I'm gonna have to hit it with something. Oh yeah. Wow, it totally dug into the plastic right there. Looks like that bushing has seen better days. This part right here, this part is fine. This part is totally fine, can easily be reused. It looks like the graphite did well. However, this axle is toast. Looks like way too much heat built up right there. But again, on this side, look at this, look at the difference. So here's this side. It looks like it had some areas where the graphite powder really stuck to. This, obviously, just too much. And it had to do with the compression, using the belt and tightening it against it. Wow. Well, let's go back there and talk about what's next. Obviously, this is a little bit disappointing. I mean, we went far considering that this was all plastic, or at least, 99% plastic. And the whole goal of this originally was to see if we could take the OpenRC F1 model and scale it up and still 3D print as much of it as possible to see if it would go. Sure enough, it went. The metal was the fasteners, which we tried with PLA nuts and bolts. Those didn't work very well. This metal plate and a very small piece of metal in the wing front thing. The tires worked well, the frame withheld, steering worked crazy well. Once we limited the motor to how fast it could spin, we could have been going for a long time. So next steps, of course, are to introduce a bearing, and not even to the front wheels at this point. We've proven that this graphite powder between plastics will allow us to reduce the friction, which means it's not going to heat up, and which means we're not going to approach heat death. The reason that this failed is because we're tightening this belt against this, which is, this is right here, and it's pushing or pulling this against. It's pulling it and pulling it and pulling it, which is creating extra friction, extra pressure, extra heat, and that's why we get a failure of the parts. We don't have to find bearings that are exactly the size. We just have to find bearings within the outer diameter and within the inner diameter of the pieces that we're working with, because then we can create little bushings that go there. Again, the idea is we just want to reduce friction, which reduces heat, which reduces the failure mechanisms of everything that's going on here. This was impressive. I'm glad we got it to this point. Let's thank a few people, first of all. I want to thank Daniel Noré for the design, and I want to thank Matter Hackers for sponsoring the filament for this build. My buddy Adam and Castle Creations, Castle whatever the remote control, they were a big financial help to this build, and I thank them very much. A big, huge thanks to Robert, who not only mounted this, made this battery, put in the servo for steering, got it all configured, helped with the graphite powder. Thank you again, Robert. I really, really appreciate your help on all this. And don't worry, you'll be one of the first ones to get the bearings in here. I wouldn't let you miss that. Big thanks to Bill over at Punish Props Academy for who taught us all about gluing and adhesion and putting some stuff together. Big thanks to my wife and my kids for supporting me on this project. Big thanks to Graham over at Full Layer Media. He's the one that filmed the interview that I had with Robert about the electronics, and he was also running the red camera out at the location where we filmed this running. Jerry, you know him as Barnacles. He actually provided some footage as well with his iPhone on a gimbal. Big thanks for coming out for the fun, Jerry. So in 2019, here's what's going to happen. We're going to get bearings, we're going to put it all together, and then we're going to make it go a lot faster. Thanks for coming along on this journey. Sorry it took so long, but we did learn a lot, and I'm excited for what 2019 has to offer. Don't forget to hug each other more. I love you guys. As always, high five.